So I want to take some time and talk to you about 5/8 special right triangles. What I want you to be thinking about as I'm talking and as you are writing this down in your notebook, what I want you to be thinking about is, why do you think these triangles are special? What is so different about what is so great about these triangles versus regular right triangles? Because these ones are special. Okay, so make sure right now that you got this at the top of your notebook. You have your title, you have your essential question. Please make sure you got that right now. Okay, here's our first one. First one's called the 45-45-90 triangle. And this 45-45-90 triangle, we actually looked at a little bit yesterday, right? We found out, we measured a lot of isosceles right triangles and looked at some of their information. And they had two congruent sides, right? That's what that keyword isosceles means, is two congruent sides. Basically, the triangles look like this, right? We had a 45-degree angle, a 45-degree angle, and a 90-degree angle, right? And then we had A, B, and C. A and B were two legs. And in this particular triangle, something that makes it special is that this leg and this leg are identical. They're congruent, right? If this one's 5, then this one's 5. If this one is 90.6, then this one is 90.6. A and B are congruent, right? The hypotenuse is longer. The hypotenuse, being across from the 90-degree angle, should be longer, okay? And what makes this awesome, which makes this greater than a regular triangle, is that it's not just a squared plus b squared equals c squared. What it is that the hypotenuse equals the square root of 2 times the leg. So if you know the length of the leg, you can find the length of the hypotenuse. Okay? And if you know the length of one leg, you can find the length of the other. You can also go backwards. If you know the length of the hypotenuse, you can find one of the legs. These triangles have so much information to share with us. Okay, I want to show you how this works in action. So here's a quick example for you. Make sure you have this written down. Pause it if you need to. Here we go. Okay. Now, the hypotenuse equals the square root of 2 times the leg. So let's see how this looks if we actually do it in terms of math-wise. Here's a triangle. I'm supposed to find x, and I'm supposed to find y. I know the hypotenuse is 8. Hypotenuse because that right angle corner is pointing to it, saying, hey, look at me, I'm the hypotenuse, yo. Okay. So, hypotenuse equals the square root of 2 times the leg. My hypotenuse is 8, so I'm going to put that here and substitute it in for the hypotenuse. Equals the square root of 2 times the leg. Now the leg I picked, or the variable I picked, was x, because that's just made more sense, right? I could have picked y. These are both legs. Okay. Now in order to get x by itself, I'm multiplying here, so I'm going to divide by the square root of 2. That'll make this cancel. 8 divided by the square root of 2, that'll actually give us our answer. And so what we're going to find out here is that x equals 5.7. Okay. 8 divided by the square root of 2, 8 divided by 1.4141, that's going to equal 5.7. So x here is 5.7. What makes this cool is we also now know y. Since they are triangles isosceles, which means there's two congruent sides, x and y being the same, then y is 5.72. Notice which 2 I used. I'm not talking about 5.72 like a number. I'm talking about also 5.7 since the legs are congruent. So we have 5.7, 5.7, and 8. So cool. Okay. Second example for you, just because we can. As we look at this one, now I know the length of the leg to get me started. I need to find the length of the other leg, and I need to find the length of y, and y is the hypotenuse. Okay. Just right off the bat, since the triangle is isosceles, since it's 45-45-90, x is also 6. The legs are congruent. If this is 6, if this leg is 6, then x, this leg, is also 6. Okay. Now we got to do a little more work to find out what y is, but we know the hypotenuse equals the square root of 2 times the leg. Okay. So if I plug in y for the hypotenuse, right, because the hypotenuse here is y, and I plug in 6 for the leg, because the leg here is 6, then y equals, the hypotenuse equals the square root of 2 times 6. So y equals 8.5. Okay. So that's going to be our solution, right? That's going to be how long our hypotenuse is. Interesting. As the leg went from 5.7 up to 6, then the hypotenuse also increased a little bit too. That should make sense. That's one special type. 45-45-90 is one special type of triangle. The second special type is a 30-60-90 triangle. I don't know why it's giving away the punchline, but pretend like that's not there, I guess. Here's a picture of a 30, 60, 90 triangle. It's got a 30-degree angle, it's got a 60-degree angle, and it's got a 90-degree angle. And it has a short leg. I'm going to call my letter A the short leg here because it's shorter than B, the long leg. And then, of course, C is the hypotenuse, the longest side. Now, because we have some different lengths here, we actually have two formulas for a 30, 60, 90 triangle. The first one is this. The hypotenuse equals 2 times the short leg. So whatever the short leg is here, the hypotenuse is twice as long. Then the long leg is the square root of 3 times the short leg. So if this is the short leg, the long leg is equal to whatever the square root of 3 times that number is. Okay? So whenever we work with these, we're going to have to do two formulas. Okay? Get this written down, get this in your notebook. Please make sure these are written correctly. Those are important. Okay? So here we go. Now, here's our formulas. Here's the picture I want you to be looking at. The formulas say that the hypotenuse equals 2 times the short leg. The long leg equals the square root of 3 times the short leg. Right now, think to yourself, which one's the short leg, which one's the long leg, which one's the hypotenuse? Ready, go. I'll give you 3 seconds. Okay, short leg. Which one's the short leg? Well, right here, X is the short leg. We know it's the short leg because it's across from the 30. Goldilocks. Smallest angle, smallest side. Hey, that's baby bear, yo. Okay, so X is the short leg. Long leg is Y. It's across from the 60. It's like a mama bear. And then the hypotenuse is 10 because it's across from the right angle. It's the longest side. Now, the information, or the leg or the side of the triangle that I have a number for here is what? The only one I have a number value for is the hypotenuse. So it makes sense that we should start with the hypotenuse formula. If that's what I have a number for, that's the formula I need to use. I know the hypotenuse is 10, I'm going to start with the hypotenuse formula. Okay? That's kind of it. It's a strange piece of information, but it will help you so very much. Whatever side you know something about, that's going to set up the formula for you. If you know the long leg, then start with the long leg formula. If you know the short leg, I guess you can kind of pick. But here, we know the hypotenuse, so we're going to start with the hypotenuse formula. The hypotenuse here is 10. So 10 equals 2 times the short leg. So 2 times x is going to equal 10. Now, some of you know the answer, but divide by 2 anyway. And x here is 5. So the length of the short leg is 5. So now I know the hypotenuse and I know the short leg. Knowing that short leg is super key for being able to work with the second formula, right? And that second formula says that the long leg equals the square root of 3 times the short leg. I can't use this formula until I know the short leg. Well, whoop-de-doo, we know the short leg. The short leg is 5. So when we plug in y equals, because the long leg is y equals the square root of 3 times 5. We grab our calculator and we get 8.7. Okay. So the length of the long leg is 8.7. So this triangle is 5, 8.7, and then 10, the hypotenuse we knew. Okay, so a quick replay. We know the hypotenuse here, so let's start with the hypotenuse formula. Substitute in, find the short leg. Once we know the short leg, use the short leg to find the long leg. Substitute in, and then multiply to find what the long leg is. So then you'll have all 3 sides. When you finish, you should know what all 3 sides of your triangle are, whether it's a 45, 45, 90, or whether it's a 30, 60, 90. Okay, these are special, and so treat them that way, please. Okay, you're going to have a worksheet. First 2 on the worksheet are done for you. If you need to, go back and reference these to help you figure out some of the rest of them. Make it happen, people. I know you can do this.